Alright, so in this quick video, we'll be going over ortho, meta, and para positions. So this is going to be an important concept that you are able to, understand, especially for future topics such as, directing groups. And so without further ado, let's just get into the video. So when we're talking about ortho, meta, and para positions, these are all just positions or, relative positions on our benzene ring here. And so what are they relative to? Well, they're relative to the carbon that has a substituent. So if we draw our benzene here and say we put some substituent X on this carbon, the ortho, meta, and para positions are going to be found relative to this X. So what I mean, initially, again, we can just draw them out, is if we have our substituent on this carbon, well, our ortho positions would be these two carbons. So these would be our ortho, these would be our meta, and this carbon directly opposite to our substituent will be the para. So here we have O for ortho, M for meta, and P for para. So this ortho, meta, para system is just a more efficient way of addressing these different carbons or that make up our ring here. So if we were to take a minute and get rid of this, let's say, and draw a different benzene with our substituent in a different position, can you see if you can pause the video and try to identify these three positions, our ortho, meta, and para? So let's say we have our benzene ring here, and in this case, our substituent is on this carbon. So take a minute and try to identify the ortho, meta, and para positions on this benzene ring. So you'll notice that here our ortho positions are not these two, our meta are not here, and our para is not this position. We can see that it's all jumbled up a little bit. We can notice that if our substituent is here, and we call this, say, the primary carbon, the carbon containing our substituent, let's call it the primary carbon, carbon number 1, and here is our carbon number 2, these are our carbons 3, and this is our 4th carbon here. If we want to use look at it like this, well then the carbons on our second position, the ones that are directly adjacent to our substituent containing carbon, those are going to be your ortho. So this is our ortho position for this ring. Here will be our meta position. And here is our para, the one directly opposite to the carbon containing the substituent. So you can see that these positions are not something that is fixed in space necessarily. They're going to vary based on the location of our carbon containing substituent. So let's try another example. Let's say we now redraw this ring in this way. We again have our standard benzene ring here. The circle is just delineating our simplification of the 3 double bonds that would make up our benzene. But now let's say our carbon that contains the substituent is this one. So take a minute to try and identify the ortho, meta, and para positions on this benzene ring. So you'll see that, hopefully this is a bit clear now, that this is our ortho, this is the meta, and this one, directly opposite to our substituent, is the para position. So these are going to be dynamic, right? They vary based on the location of the substituent. So now why do we have this nomenclature? Well, that goes back to a concept, or that's going to be covered in future videos, right? That's going to be things like activating groups, deactivating groups, these different directing groups, right? And just as I get, I guess, maybe a bit of a spoiler or sneak peek, what these are referring to is the position of that substituent. Again, the identity of the substituent, as well as its location on the benzene ring, let's say it's over here, is going to influence the location in which other groups will attach. So if we have now a substituent here and we undergo some EAS reaction with some electrophile, the position that this electrophile will end up attacking would be different based on the identity of this substituent. If this substituent is an electron withdrawing group, the electrophile may attach in a different location than if this was an electron donating group. And this is all things we will cover in a future video, but in that video we will be pretty fluidly using this ortho, meta, and para language, and so it's important that you're able to identify these positions with ease and understand exactly what we are referring to. So please take some time to draw out other examples and put the substituent on different carbons and try to identify the ortho, meta, and para positions relative to your substituent. And also just get familiar with this language when it comes to referring to different carbons on our benzene. So that brings us to the end of this video. Hopefully it was helpful, and if it was, please show your support by liking and subscribing, and leave any questions or suggestions for future videos in the comments, and I will see you in the next one.